present on the flow and resource efficiency measurement method in offsite production. So Brian, you heard the instructions, so 10 minutes, I'll give you the warning. 3 minutes, 1 minute.
Yeah, thank you very much. Good morning, everyone. My name is Brian Werniger, and I'm representing Luleå University of Technology in Sweden. And for the next minutes, I will present you my paper named Flow and Resource Efficiency Measurement Method in Offsite Production. It's an interesting, important issue, I think, and ongoing from the yesterday's discussions we had. We cannot make everything that counts countable, but we can support the supply chain strategy and the lean strategy of the companies with relevant metrics, and this is one work in that direction. And I will introduce you to the work by explaining flow and resource efficiency. When I talk about resource efficiency, I quest how much we utilize a resource under a certain time. The target is minimization of direct production costs with its origin in mass production, and we can calculate it as a usage of resources in relation to the available time interval. When I talk about flow efficiency, I quest how much value the resource is transferred to the product or flow unit under a certain time. The targets are high delivery performance, low tied-up capital, short lead time, minimizing of total costs. With its origin in the lean philosophy, we can calculate it as a value-adding rate, the value-adding times in relation to the throughput time. Both sides represent important issues for companies. That's why they have been visualized together in this diagram, showing the conceptual model of my work. Resource and flow efficiency are visualized as competing targets. There might be some tension in between, but there is a possibility of reaching a balanced position in the upper right corner. Out of the conceptual model, different questions emerge. Are the figures measurable in construction? Do the results make any sense? And for that reason, I defined the following research aim: the evaluation of a possible flow and resource efficiency measurement method in the offsite production context of volumetric element construction and assessing the industrial relevance. We limit that work to the offsite production, and it was a kind of a win-win situation with the company. The company has invested quite a lot in its offsite production system, and efficiency-related questions are very high important. And from a research point of view, the offsite production system is a little bit more stable, and we were able to plan and even test and these kind of things. So we chose a case with a contractor, a rather small project, 2 residential houses, 16 apartments total, with 42 volumetric elements prefabricated in the main offsite production system. The flow units of the study are the volumetric elements and the planar flow elements. And similarly designed volumetric elements have been classified in 6 different flow unit types. 2 examples I have here on 2 pictures. On the right side, the type living room, more simpler volumetric element, and on the left side, one of the 2 flow unit types, kitchen and bath. You see the kitchen and the front and the baths beside the entrance at the end. The picture shows the layout of the part of the production system, and the yellow zone, I don't know if you can see it, it shows the observation zone of the case study. Flow is like this from the floor line, assembly here, and 3 parallel final assembly lines. We left the wall element line and the ceiling element line outside the case, and even the wrapping and the storage after. So we limit the size of the case, and we target a lot of challenges for the measurements, and even if we limited the size and had a rather small project, time studies and measurements like this were not doable. The second challenge is a really interesting one: flow units and operators moving in the system. Because one could say that, okay, this is offsite production, this is not even construction, this is very close to lean manufacturing, and you can just copy Toyota's production system and everything will be fine. But it's not that easy in practice, because we do not only have the variation of the construction industry with the project and the products, we even have both flow units and operators moving in the system, the operators between the workstations and the lines, and even between the lines and the final assembly area. And the last challenge, there was not sufficient data available from the production report system. So we chose work sampling as a work method with 15 minutes observation intervals instead. And each observation consists of when, where, which flow unit, who, the number and team belonging of the operators who were working with the flow unit or not, and what kind of activities that was going on. We classified in value-adding activities, supporting activities, rating and unclear activities. Let's move on to the data analyze. With the flow unit observations, we could calculate flow efficiency, and with the operator observations, we could calculate resource efficiency. 5,560 flow unit observations. We got a result of the flow efficiency according to that diagram. Both kitchen and bath types, for example, reach almost 50%, meaning that they receive value 50% of the throughput time in the system. The living room just reached 19%. In the same way, we calculated resource efficiency with 4,932 operator observations. More even result. The highest was reached by the living room, 92%. Both flow and resource efficiency are combined visible in the star diagram as dots for the different flow unit types. Just short the result, the resource efficiency is on a higher level compared to flow efficiency, which spreads more about the flow units. And we did not reach a kind of a balanced position. To check the validity of the measurement method, we compared the observed results with the figures from the case company's cost estimation system. All the green columns add together represent 100% estimation of the workload, and all the orange columns added together represent the observed results. Some of the results are in line, for example, the 2 bathrooms and the stairwell flow unit, while there are differences. For example, the living room, which is estimated the most workload flow unit type, while the kitchen and bath type units are observed more workload intensive. Let's summarize the results with the conclusion of the work. Combined measurement of flow and resource efficiency are possible in the offsite production context of volumetric element construction. The method delivers figures to enable discussions about differences and similarities and possible improvements of the system. Work sampling can be used as method for data collection, but it still has been a time-consuming method, even if the object was chosen quite small. And the balance between flow and resource efficiency is an important issue for the case company. There was a product manager who really pointed out that this was really interesting because that's what he made in his daily work. In one meeting, like how can we improve the flow and how can we reduce throughput time, and the next day he just asked for the productivity and how many hours did you spend last week. So that was really what he think got to the point. Yeah, the results and conclusions still leave questions for future research. The evaluation in different cases and contexts. For sure, on-site production is an interesting case, and questions for more validity and statistical methods. Yeah, finally, I would like to thank my financial sponsors, the Wood Center North and the European Union Structural Funds, the case company who strongly supported me, my colleagues Helena Liedelöf and Lars Stein, who worked together with me on that paper, and finally you for your attention. Thank you very much.